Hi, welcome back to Python 3. Today we're going to be covering libraries and CSV files. So let's begin and get into Jupyter Labs. So we're just covering 3 topics today and 1 action as well, uploading files. But we're going to begin with libraries. So what does coding have to do with books? Well, not much, but libraries hold lots of information, and so too do coding libraries. We've mentioned plotting graphs so far, but we haven't mentioned any functions to do that. This is because we need to import a library that contains these functions for us. So first, let's begin by importing a simple library, math. So we've got this cell here that says import math. Now, import is the key word for importing a library. The syntax for importing libraries is import and then just the name of the library. So now that we've brought math into our textbook, we can do this function here that's from the math library. Referencing a library during a function call looks like this. We've got the name of the library, dot, and then the function name from the library, and then just the same as any other function, we input our actual parameter, and once we execute the cell, we can see, well, square root 4, well, square root 4 is 2. So it's worked. So this is a simple referencing of a function from a library. This might remind you of the append function, which only works on the list data type. So using any function from a library requires you to first name the library first, okay? And then type a full stop, then type the function name, okay? And then enter the actual parameters in enclosed brackets. Just the same as any other function, very similar to append, just instead of the variable name, it's the library name, because this function is from that library. Now, we can make our own names for libraries as well. What do I mean by that? We don't get to rename them, no, but we get to make a referencing name for them. So say I want to type very quickly. So for the math library, something like just M would work. I can type M pretty quickly, and I'm still going to understand what I'm referencing as well. So we can change the name of the library when we import it in, just like this down below. So in this cell here, we've got import math as M. Okay, we've used 2 keywords here. We've used import to bring in the name of the library math, and then as, and then the new referencing name, okay? I hope this reads pretty naturally. So import math as M, import this library as this name. That makes sense? So now that we've changed the name of the math library to M, we can use, so where we typed math before, we can now shorten it to just M. When I execute this, you can see it's worked. It's recognized that square root comes from the math library, and we've called it M. It works all good. So now that when we call functions in the math library, we can just type M in place of math. You can do this for every library you import in, and it's highly recommended you do so for libraries that have longer names. I will give examples later for you that are standard in computing, and they'll help others to understand your code as well. So I've got a list here of the libraries for laboratories, the libraries used in first year physics, and most of physics beyond that as well. These are the main scientific libraries for physics. A wee explanation of their purpose and also the common referencing name for them as well. So the first library is called matplotlib.pyplot. The referencing for this is we import matplotlib.pyplot as just PLT for plot. And matplotlib basically contains functions for plotting graphs and adjusting settings in those graphs as well, like adding a title or changing the grid with your major grid lines, your minor grid lines, things like that. It's a vast library, and it's commonly used to display data in scientific research. And you will use this to plot all of your graphs using its functions. The second library is Pandas. It's quite a fun name. We reference Pandas as import Pandas as PD. Okay, PD shortened for the P and D in the beginning and middle of the word. So Pandas is a library used for data analysis and manipulating data into many forms as well. We'll be using Pandas to read in the gathered data from Excel contained in our CSV files, which we'll get into in a little second. The third library is Numpy. It's pronounced Numpy, not Numpy. Who calls a library Numpy? The referencing is import Numpy oh no. import numpy as NP. Numpy is a library used for working with arrays. Arrays are laid out like a matrix in mathematics, and we will use numpy when we draw lines of best fit for our graph data. The fourth library is Scipy. The referencing is import Scipy as SP. Scipy uses NumPy. It uses the library NumPy for more advanced mathematics. It's unlikely you'll use Scipy. It's unlikely you'll use Scipy for first year laboratories. But if you do, it will be used in a similar way to NumPy, just working with arrays and applying mathematical transformations and calculations to those arrays as well. And the fifth one that you might want to use is math. So referencing is either just import math or import math as N. It's really just down to personal preference if it's shortened or not, because it is quite short. It contains mathematical functions you will have seen from school and some more complicated ones as well. Examples of the functions are square root, sine, cos, and the factorial function as well. It'll be up to you if you want to use a math function in your labs. You won't be told explicitly when you need to use one, so it's up to you if you go, I've spotted that this can be done with a function in math, and you're free to use that. You're not restricted at all to the libraries or functions that you use, just as long as the job gets done properly. So now we're going to switch over to an Excel demonstration of uploading CSV files and also changing an Excel file into a CSV file. And what is a CSV file? So let's hop into Excel for that. Whoa, okay, we're in Excel now. I'm in Excel. So up here, we've got our data. We've got two columns, okay? At the top, we label our columns with the names. So this is experimental data that I've gathered from putting different masses on a spring balance, okay? And then measuring off the force that spring balance is telling me. So we've got the mass down here in the first column, okay? This is our independent variable that we've gathered, okay? I've selected the masses to put on, and the dependent variable is what I've measured. So I've measured the weight value from the spring balance. So this is our data, and we're going to bring it into Python now. To do that, we need to change it into a CSV file. A CSV file stands for comma separated values. Okay, it's just a big long list, and all the values that are in your Excel file right now will be separated by commas. So to export this Excel file into a CSV, go up to File, down to Export, change file type, okay, and it's down here, okay, just CSV, comma limited. This one here. You click on that, you click Save As, you can save it as a file in your computer, and now we're going to go back to Jupyter Labs in order to upload this from our computer. So remember, I'm not going to save it right now because it's already uploaded, but you would save it onto your computer drive, okay, or just the desktop, whatever you're using right now. And then we're going to hop back into Jupyter, okay, here we are. And to upload something, you click this button up here, Upload Files, and that is going to open your file navigator, and you can go in, select the CSV file from your computer file system, and then just click Enter, and it will upload, and it will appear in this whatever folder you're in right now. So make sure you upload it to the folder that contains the notebook that you're currently working on. So when we open a CSV file in Jupyter Labs, this is what it looks like. We've got our number of entries down here. Again, inconsistent because it doesn't start counting from 0. What's that all about? We've got the names. The labels are important. We're going to come back to these in the next video. They're very important in CSV files and very helpful as well. They make life easier for us. So we've got our mass values down here and our weight values down here. And that is uploading CSV files. This is what they look like. In the next video, we're going to cover some basic graph plotting. Okay, this is what we've been leading up to. This is the end of the sort of basics of Python, and now we're getting into the basics of graph plotting. So this is actually getting into the laboratory stuff now. So that's Python 3. I'll see you in the next video. Thanks for watching. Bye.